Hey everyone, and welcome to this tutorial on how to communicate between Arduino and Raspberry Pi using serial communication. You will set up the hardware and the software correctly, initiate the communication from both sides with C++ on Arduino and Python on the Raspberry Pi. Then you will learn how to send some data from the Arduino to the Raspberry Pi, from the Pi to the Arduino, and finally you will create a complete bidirectional communication. All that in just 1 hour. And if you want to go further after this, I have a course on Raspberry Pi and Arduino which contains 9 hours of video content where you will put everything into practice to build a complete intercom project using serial communication, the Raspberry Pi camera, a Telegram bot, a servo motor, and much more. You can find the link in the description. And now let's get started. In this lesson, I will show you how to install the Arduino IDE on the Raspberry Pi so you can program your Arduino directly from there. And let's first understand very quickly why this can save you a lot of time. So if you already have the Arduino IDE on your computer, what you can do is to write some program for your Arduino. Let's say you are on Windows, Mac or Linux, it doesn't really matter. And then you upload the program to the Arduino. Then, when we will make the Raspberry Pi and the Arduino communicate between each other, you will need to unplug the Arduino from your computer, plug it to your Raspberry Pi, and then run a Python program to communicate on the Raspberry Pi. And every time you need to modify something in the Arduino code, you will need to do this process again, which is basically to unplug from the Pi, plug to the computer, upload, unplug, and plug to the Raspberry Pi again. Now what you can do is directly install the Arduino IDE on the Raspberry Pi OS. By doing that, you can keep the Arduino board plugged to your Raspberry Pi board. Anytime you need to modify the Arduino program, you simply need to stop any current program running on the Raspberry Pi, which is communicating with the Arduino, and then you just upload the code and run the program again. That's it. Alright, now let's go to the Raspberry Pi OS desktop and install the Arduino IDE. So Raspberry Pi desktop is actually Linux, so we are going to do the Linux installation. And if you open a terminal, well, you could install Arduino IDE directly with apt, but don't do that, okay? So you could do sudo apt install Arduino. You may see that in some tutorials, but don't do that because this version is actually old and not updated. So you're not going to have the new features and maybe that's not going to work. So instead, we are going to open a web browser here on the Raspberry Pi and just type Arduino IDE. So just search on DuckDuckGo or Google or whatever search engine you want. Let's go to the Arduino website. And here we are not on the right page, so let's go to software. So you click on software and you have downloads, okay, Arduino IDE. So just download the latest Arduino IDE version, okay, it doesn't really matter which version you have for now. So on the right, you can see the download options. Okay, so if you were to use Windows or Mac OS, instead of the Raspberry Pi to actually program your Arduino, then download one of those. But here we are on Linux, okay, we are on Raspberry Pi, so we are on Linux, so we're going to download one of those here of Linux. And to know if you have 32 or 64 bits, well, it's simple, just open a terminal again and do uname space -m. This is going to show you that, and if you see ARMv7L, it means you have a 32-bit. If you have something like x8664, you have 64-bit. So we know we have 32-bit here, and we are going to use the ARM32. So you download that one. Okay, you can just click on just download. And you can see it's going to download it here. So you just wait until it has been downloaded. All right, we now have the Arduino IDE downloaded. So I'm going to close this web browser and let's open the terminal again. Alright, and as a remember here, you have to have some basics on Raspberry Pi, including the terminal, so I'm going to show you exactly what commands I use, but I'm not going to explain everything 100% from scratch. So we are in the home directory. I'm going to go to the downloads folder. Okay, in the downloads folder, we have this. So that's the archive we have downloaded from the Arduino website. This is a tar. Okay, so we are going to do tar space dash xf with the name of the archive. So you can just use the auto-completion with tab if you want to go faster. You press enter, you wait a few seconds, maybe even a few minutes. Alright, and when the command returns ls, you see we have a new folder which contains the Arduino IDE. Now what you're gonna do is to move this inside the /opt folder of your Raspberry Pi. So you're gonna do sudo because we are going to put that somewhere else than in your home directory. So sudo mv to move. You just use the auto-completion to select the folder, and then you do /opt with auto-completion also. You press enter. All right, now the folder is gone. You go to cd, so cd/opt ls. We have other stuff here as well, and we have the Arduino IDE. So we are going to go inside this Arduino folder, and now you can see we have this. So we have a few scripts here and some folders, but basically what we're gonna do is to run this install.sh. So sudo /install.sh, and you wait a few seconds. Okay, and when you see done, well, Arduino IDE is successfully installed. Just one more thing is, if you want to uninstall it, you just go back to this folder here and you just run the uninstall script. And then you can also remove that folder if you want to. All right, but let's keep Arduino IDE installed. I'm going to close the terminal now, and you can see here we should have on the menu programming, and we have a new Arduino IDE icon here. So I'm going to click on that. Okay, and the Arduino IDE is now open, and you see you have a new program here. And now just one or two things about configuration, okay, so that you can have a better looking IDE and that the code can be more readable. You're gonna go in File, Preferences, and you can edit here different things. For example, editor font size, I'm going to put 14 here. I'm going also to use display line numbers. Okay, so I'm going to change those two options here. Let's click on OK, and you can see it's already better. I'm going to go back to Preferences, and where you already have another information here is where your sketchbook is. So sketchbook is basically where your Arduino programs are going to be saved. So you have a new Arduino folder here on your home directory. And the last thing I'm going to do is I'm going to go down here. More preferences can be edited directly in the file here. So I'm going to click on that. This is going to open a new file manager, and I'm going to close, that's very important, you're going to close the Arduino IDE. Okay, we are going to modify preferences.txt here, and before you open that file, you close the Arduino IDE. Very important. So you double click, it's gonna open the file, and this is because we're gonna find this line, okay, editor.font. Okay, so you can just scroll and find this line, editor.font. You see we have monospaced by default, and this may actually not be the most readable font for Arduino. So what you can do if you want is to change to consolas here, like this. You write like this, consolas, and then you have plain, so don't touch anything here. Anyway, that setting doesn't work. And then you see you also have the font size that we have just set before. But for the font, basically there is no way to change it on the Arduino settings, so we have to open this preferences.txt file. So I'm gonna save with Ctrl S, and now I quit the file, I quit that, and let's go back to Arduino IDE. All right, now we have a new font size and a new font, and we have the line numbers. So everything is good for the course. Now, if you plug your Arduino to your Raspberry Pi with the USB cable, then you go on Tools, you select Board Arduino Uno. So if you have an Arduino Uno, of course, if you have something different like a Nano or Mega, you choose the correct board. And then on port, you're gonna choose the Arduino Uno port. So usually that's gonna be something like TTY ACM 0 or TTY USB 0 or with 1 or something like that, okay? So you select this, and then let's just upload an empty program to see if it works. So compiling, uploading, down, uploading, great. Everything is correctly working. All right, so now we have all the tools we need. Let's jump straight into the serial communication so we can make the Raspberry Pi and the Arduino boards talk to each other. Let's directly dive in and make the Raspberry Pi communicate with the Arduino. Now, how are we going to make those two boards communicate between each other? Well, we are going to use serial communication. And what is serial communication? Basically, serial communication is simply a way to transfer data between two devices. More specifically, serial is based on the UART protocol, which means Universal Asynchronous Reception and Transmission. If this sounds complicated, well, this is not. Asynchronous reception and transmission simply means that you can talk from the Raspberry Pi to the Arduino and from the Arduino to the Raspberry Pi at the same time. Just like when you are chatting with someone on your phone, you can send messages and the other person can send messages at the same time. Now, don't worry too much. We won't need to dive into the low-level details because there are some high-level libraries that we can directly use in our code and which will make things easier. In fact, you probably already know serial communication. If you were using the serial monitor on the Arduino IDE to debug your Arduino, well, this is serial communication between your Arduino board and your Arduino IDE on your computer. What we will do now is that instead of communicating between Arduino and the serial monitor, we will create a communication between Arduino and a Python program on the Raspberry Pi. Alright, and let's get started. Let's start with the hardware setup for serial communication. So you have your Raspberry Pi here, and you can see it's already powered on for me, okay? And you have your Arduino and the USB cable. So what you're simply going to do is connect the Arduino to the Raspberry Pi with the USB cable. As you can see, you can do that when the Raspberry Pi is powered on or powered off. It doesn't really matter. And that's pretty much it. Now you can see also on the Arduino here, I'm going to unplug it here. You can see you have some pins here on the Arduino Uno. You have 0 and 1, which are RX and TX, and those are also pins for serial communication. So you could use those eventually with some GPIOs on the Raspberry Pi, but this is much more complex. Okay, you need a voltage level shifter between 5 volt and 3.3 volt. It's also less robust, less reliable, and well, USB cables are really working well. Okay, I've never had any problem with serial communication that way. And one more thing is that, so here I have an Arduino Uno. You may have a different kind of board, okay, and depending on the board, the USB connector here may be different. So here I have like a standard classic one, but you may have a micro USB. Well, it doesn't really matter as long as you can connect the USB connector here to the USB connector here on the Raspberry Pi, everything is going to work correctly. Now that the hardware setup is down, let's do the software setup, and for that you go to your Raspberry Pi desktop. So make sure, of course, that you have correctly plugged your Arduino board to the Raspberry Pi using the USB cable. And so for the Arduino side, there is nothing to do. Serial is already configured and ready to be used with the serial library. On the Raspberry Pi board, we will need to do a few setup steps. So first of all, you can open a terminal here. So click on the terminal icon and do ls-dev port-tty, and then this, so we can list all of the stuff that starts with /dev/tty. You press enter and you can see all of that. So what is this? Well, basically we are going to try to find the port of the Arduino on the Raspberry Pi, okay? So the port is basically the name that is given to the port here so that we can recognize it and then we can connect to it. And well, you have quite a few. I'm gonna give you the answer. The port is that one, okay, /dev/tty-acm0. So you should have something like this, tty-acm or tty-usb, depends, with a number that can be 0, 1, well, usually you will start with this. Now, how to be sure you have this port? Well, you simply disconnect your Arduino. So I just unplugged my Arduino board, okay? I just unplugged the USB cable and now I'm gonna run this command again. And you can see that here we don't have the tty-acm0 anymore. Okay, I'm gonna replug the Arduino. The Arduino is plugged. I run the command. You can see now we have this. So basically, you just disconnect your Arduino, you run that command, you connect your Arduino, and you just find what is the new port that is here. So now we know that this is the name of the port. What you could also do is, if you have the Arduino IDE installed, okay, you can see here on Tools and Port, we can find also the same name, all right? So now we have the port. I'm going to do clear on the terminal. The second step we need to do is to make sure that our user, so the Pi user, which is here, you can see, has the permission to access to serial communication. So we're going to do groups to see all the groups we are in, okay? So as the Pi user, you can see we are already in the dial out group, and this is the one that gives you access to serial communication. So if you don't have this when you type groups, so what you can do is sudo add user and then the name of your user. So here it's Pi and the name of the group. You press enter and you can see here the user Pi is already a member of dial out. But if it was not the case, it would add you to dial out group. Okay, if you just added your user to the dial out, you need to log out and log in. So what you can do is log out, log in, or you can also reboot your Raspberry Pi so you can be sure. All right, that was the second step. The third step is to install a Python library. So on the Arduino side, we have the C++ library called serial, which is already installed on the Arduino. But on the Raspberry Pi side, we need a Python module, and this Python module is PySerial. Okay, so we are going to use the PySerial module, and to install it, so first make sure you have pip3. So if you don't have pip3, sudo apt install python 3-pip. Okay, it's already here, and then pip3 install PySerial like that. Okay, press enter. And already installed. So actually, it may already be installed on your Raspberry Pi. So if that's the case, that's wonderful. And then you can do pip3 show PySerial, okay, to see the version, to see more details, and maybe the page with documentation and everything for this library. And that's pretty much it. Okay, great. So now everything is correctly set up. The Arduino board is plugged to the Raspberry Pi with the USB cable. You have the correct permission on the Raspberry Pi, and you also have a serial library ready to be used on both sides. Let's now initiate the communication. Now that everything is correctly configured, let's start the communication. In this lesson, we will just initiate the communication, and in the following lessons, we will exchange some data between the two boards. So we are going to open the Arduino IDE so we can upload some code to the Arduino board. And we are also going to open the Thorny Python IDE so we can write some Python code on the Raspberry Pi. So I'm going to organize like this. Okay, so I can have the Arduino code on one side and the Python code on the other side. Okay, so this is going to run on the Arduino. This is going to run on the Raspberry Pi. And as you can see, that's very practical that we have the Arduino IDE on the Raspberry Pi, so we can directly write the two programs on the same place. And we are going to start with the Arduino side. Okay, usually that's what we're going to do. We're going to start from Arduino because that's going to be easier to debug. So to start serial communication, well, you just do serial.begin with a baud rate. So that is a quite classic baud rate, 9600. Okay, and you put this line inside the void setup of your Arduino. Okay, you have void setup, which is going to be executed once, and void loop, which is going to be executed an infinite number of times. So with this, we have initialized serial on the Arduino. So that's very simple. What we can do also, and this is going to depend on the Arduino board that you have, is do while and then exclamation mark for not serial, and then just open close curly brackets. So this basically, on the Arduino Uno, for example, or Nano or Mega, you don't need this line, but if you are using an Arduino with a native USB, for example, Arduino Leonardo or Arduino Zero, then you may need to use this line, otherwise the serial is not gonna work correctly. So basically this is going to wait until the serial is ready. So I'm just going to include it here and in every program I do, so that this code is gonna work on pretty much any Arduino board. But if you are using Arduino Uno like me, you don't need this. All right, so that's the code for the Arduino part. Now I'm going to go on the Raspberry Pi part and write some Python program. So let's first start with this user bin and with Python 3. Okay, so if we ever execute this from the terminal directly, we give the information that the interpreter is Python 3. Now what we're gonna do is we're gonna first import serial. Okay, so the name of the library is PySerial, but you're gonna import serial. Okay, on the Arduino you have nothing to import. Okay, serial is already there, but on the Raspberry Pi you have to import that module. And then, well, the first thing we're gonna do is to open the serial communication. And the serial communication is gonna give us something that I'm going to save as ser for serial. Okay, I do this because that's quite common, and if you find any help on the internet, any tutorial, any documentation, that's what you're gonna see. So I'm gonna keep the convention that is on the internet, right? And so ser is equal to serial dot serial uppercase with the S uppercase, you open close parentheses, and first we are going to give the port. Okay, so if you remember, the port was /dev/tty-acm0. So that is the port I have found actually in the previous lesson. Okay, so if you are not sure what port is yours, because that may be something different here, please go back to the previous lesson on how to set up serial communication, and then come back here with the port that corresponds to your Arduino. The next parameter is the baud rate. So the baud rate is actually what you can see here. That's the speed of communication basically. And this is super important. You have to have the same baud rate on both sides of the communication. Okay, if you have a different baud rate, then the two programs can't understand each other. And actually, speaking of baud rate, this is the pretty common classic baud rate you're gonna have in every tutorial, but it's also a pretty slow one. You can go up to 115,200 baud, okay, and that's the baud rate I'm gonna use. So if I use this here, I use this here also. Okay, so you can have different values, okay, you have different common values, and this is one of the most common one and also a quite fast one, and it's better than the classic 9600. And I'm gonna add a third parameter, which is timeout, let's say 1.0. So timeout here is read timeout. I'm going to come back to that a bit later in the course, okay, so don't worry about that for now. All right, so with this line, we open the serial communication, And if it works, okay, we're gonna get the serial inside this cell. If it doesn't work, we're gonna get an error and the program is gonna exit. Then what I recommend you to do is to wait a few seconds here after opening the communication. So I'm gonna do import time and do time.sleep for 3 seconds. So I recommend at least 2 seconds, 3 is even better. Because, well, when you open the serial communication on that side, the thing is that on the Arduino side, the Arduino for Arduino Uno, for example, is gonna restart. So the program is going to be restarted. So what you want to do on the Raspberry Pi side is to give enough time for the Arduino to have the serial completely ready to communicate. And so we give 3 seconds here. And I recommend you do that, because if you don't do that and you try to read some data or just send some data just after that, you're gonna experience some weird bugs in your program, and that's gonna be hard actually to debug. So better have a time.sleep with 2 or 3. And then I'm gonna do ser.reset input buffer. So what is this? So basically with serial, both sides can communicate with the other. Okay, so I can send data from the Raspberry Pi to the Arduino, and I can send data from the Arduino to the Raspberry Pi. When the data arrives, it's not directly in the code. When the data arrives, it's in a buffer. Okay, and when you're gonna read, that's what we're gonna see in the next lesson. So when you're gonna read actually from the buffer. So here we reset the input buffer, which means that if the Arduino sends us some data before this, so when the program is actually paused, we're gonna erase everything. So we start after this line with a fresh buffer that has nothing in it, okay? And I'm going to come back also later in the course to explain more about it. All right, so that's it. Now let's maybe put print serial, okay, to have a nice confirmation, and then, well, the program is gonna exit. Okay, now what to do? Because we have the Arduino program here, the Raspberry Pi program here, but what you need to do first is to upload the Arduino code on the Arduino IDE, okay? That's the first thing to do always, is to have the Arduino ready. So I'm gonna go on Tools, check that I have the correct board, the correct port, and let's do Upload. Okay, let's save it as first communication. Okay, you can see compiling and uploading and down uploading. So the code is now in the Arduino. Now that the code is in the Arduino, we go back here and I'm gonna save the file. So save as. So let's create a new folder actually. Let's go here. So I'm gonna do directly from the file manager. Okay. Right click, new folder, let's call it Python programs. Okay, and let's go back here, let's do save as in Python program, first communication .py. So that's a Python file. Click on OK, so the program is saved, and now I can run it. So to run it, I can just click on the play button here or run from the terminal. So I'm just gonna click here. And you can see we have, so we run the script and after 3 seconds we have serial OK, which means that the Raspberry Pi could correctly connect to that port, okay? So it could correctly connect to the Arduino. Now, one important thing you have to do also on the Python side is that, so here we directly exit after this. So we open serial communication and then we exit. What you have to do, and what is better, is to close the communication. So you can do ser.close, okay, before you exit the program or whenever you want to close the communication. So with this, you're gonna open the communication. With this, you're gonna close it. And on the Arduino side, you don't need to actually close the communication. Okay, the communication is gonna be closed simply when you power off the Arduino. But here, as a best practice, it's better to close it, because then if it's not closed correctly and you try to run another program, you may have some troubles. Okay, so let's run that again. You can see we wait 3 seconds, serial OK, and then we close the communication. Here, everything is good. Now, let's say that, for example, I don't have my Arduino board connected to the Raspberry Pi. So I have physically removed the USB cable from the Arduino side or the Raspberry Pi side, it doesn't really matter. And now I'm gonna run the script again. And you can see we have an error, okay? We have an error, which is quite big, but at the end you can see serial exception could not open port /dev/ttyacm0, okay? So basically the port is not found. Why? Because the Arduino is not connected. If I plug the Arduino to the Raspberry Pi again, let's run the code, and now it's working. Great. So to recap on the steps here, that's very important. First, you will need to write some code for the Arduino, where you initialize serial, of course, and you need to upload that to the Arduino. When you upload to the Arduino, make sure that you are not currently talking to the Arduino from another program of your Raspberry Pi, okay? Because when you upload and when you communicate, you use the same serial communication, okay? So if you are sending data from your Raspberry Pi to the Arduino with a Python program and you try to upload, you may have some problems. Okay, now that the code is on the Arduino, the code is gonna run as soon as the Arduino is powered on, and then you can run your Python script where you open the serial communication. So make sure you have the same baud rate, okay, and make sure you have the correct port here. And basically on some boards like Arduino Uno, Nano, Mega, for example, when you open the serial communication from the outside of the Arduino program is gonna be reset, it's gonna be restarted. So at this point of the code, this is gonna be restarted from scratch. So that's why you want to wait a few seconds. So here we wait 3 seconds, that's very safe, so that the serial communication can correctly be initialized and everything can be initialized on the Arduino side. Then you reset the input buffer, you do whatever you want to do here, you can send and receive data, that's what we're gonna see directly in the following lesson, and then you close the serial communication here on the Raspberry Pi side and you can exit the program. You've already made a lot of progress. Congratulations! Now we are about halfway through the tutorial, but if you want to get access to 8 more hours of content with many practice activities and a big project to create an intercom system with Raspberry Pi and Arduino, well, I have a course just for you. Check out the link in the description below to know more about it. And now back to the video. Great, you have now successfully initiated serial communication between your Raspberry Pi and Arduino boards. Let's now see how to send some data starting from the Arduino side to the Raspberry Pi. So this is gonna send data, this is gonna receive data. So once again, we're gonna start on the Arduino side because that's gonna be easier to debug. So on the void setup, we initialize the communication with that baud rate and we make sure the serial is ready. So that's pretty much it. Now what we want to do is to send some string, let's say hello every 1 second. So we're gonna do that in the void loop. We are going to do serial.println with hello from Arduino. As you can see, when you use serial.println or if you use serial.print, if you have ever used that before to debug your Arduino, well, that's the same thing to send data over serial. And I'm going to use println here so we can add a new line character after this string. And I'm going to add also a delay. So let's use delay for simplicity here of 1 second. So we can send that every second and not all the time. All right. Make sure that nothing is running on the Raspberry Pi, so no Python script. Let's upload the code to the Arduino. Okay, done uploading. And now what we can do before we write anything with Python, we can open the serial monitor to debug what we have. And you can see we have hello from Arduino every second. So by starting on the Arduino, when you use serial communication, you can make sure that this side is working with the serial monitor. So this tool is super useful. So now we know that the code is correctly working and correctly sending this string over serial. Okay, so that's going to be easier to debug when we actually write the Python program, because we know that this side is working. So now here, what are we going to do? So we want to be able to read this string that we receive and to print it on the terminal. How can we do that? Well, we are going to create an infinite loop here to read the string. And if you see here, basically on the Arduino, we have a void setup, which is going to run once to initialize stuff. And here, that's pretty much what we have also, okay? We are going to run that once to initialize serial communication. So this part of the code on the Raspberry Pi with Python is actually similar to the void setup we have on the Arduino. And then we have an infinite loop to read and send data. So we are going to also create our own infinite loop, our own void loop on the Raspberry Pi with Python. Okay, so we can have a structure that is similar to what we have on the Arduino. And how do we create a void loop? Well, we simply do while true, and that's it. We have an infinite loop, okay, while true. And in this loop, we are going to read serial communication. And actually, the first thing I'm going to do is do time.sleep with, let's say, 0.01 second. Okay, so here you can run the void loop as fast as you can, basically as fast as the microcontroller can. That's not a problem because anyway, the Arduino is just doing that. But on the Raspberry Pi, if you run an infinite loop at full speed, what's going to happen is that it's going to take all the resources of your CPU for just one Python program, and it may make the Python program very slow or anything else that you do very slow. So that's why I'm going to add a time.sleep with, let's use this, which means that this is going to be executed 100 times per second, which is more than enough for this lesson and also for this course. So we have our own kind of void loop. What do we do in that void loop? Well, we are going to check first if we have received something from the Arduino, and if yes, we are gonna read that thing, okay? So we can do if ser, so we use the ser that we have created here, dot in waiting. This is gonna return the number of bytes that have been received from the Arduino. So we don't really care about the number of bytes. What we care about is, have we received some data? If we have received some data, it means that the number of bytes is simply greater than 0. We don't need to count them, but just knowing that it's greater than 0 means we have received something. Okay, one very important thing here, don't put parentheses. Okay, this is not a function, this is an attribute of serial. So press enter with the indentation here. If we have received something, let's say here we are going to read the next line. Okay, so line is equal to ser.readLine with parentheses. This is going to read the next line. What is the next line? So basically the next line is going to be everything until we get this \n character, which is basically a new line character. And now you can see that's very important here. That's why I have added ln, so print ln. So basically this is going to send hello from Arduino with a new line character after this. And so on the Raspberry Pi with readLine, it's going to read hello from Arduino until that new line character that's going to be here. So now we have our line, but basically this is encoded, okay? Serial is not just going to send the string like this, it's going to encode it so it can better communicate, okay? So basically what you receive here are just bytes. Okay, if you want to read them as a string, you can do dot decode and then UTF-8. That is going to decode what you get with readLine into a correct string that you can read here. And then let's do print line. All right, so basically this is gonna run forever until you press Ctrl+C at 100 Hz. It's going to check if you have received something over serial. If yes, it's going to read it and decode it and print it. Now I'm going to do something here is, of course, I'm not going to close the communication before we actually start to use it. So I'm going to put that at the end of the program. And maybe you would see a problem here is that if we press Ctrl C inside this while loop, we are never going to go to line 16 and we are never going to close correctly the serial communication. Okay, so if I put this line here, it's never going to be called. So what I am going to do before I run the program is I am going to put this while loop inside a try except structure, okay, so I can catch the keyboard interrupt exception, and basically when we press Ctrl C, we are gonna close the communication. Okay, so let's do that now. Let's do try and put that with one more indentation. So you select everything and you press tab and then come back to new line, except keyboard interrupt like this. So basically, for example, when we press Ctrl C and we do ser.close inside the handle of the interrupt. And I'm going also to just add here print close serial communication. Okay, so we know that this has been executed. All right, so now let's run this. So the code here is already running on the Arduino. I'm gonna run here from the Raspberry Pi. Okay, so you can see serial OK and then hello from Arduino every second. Great. Now I'm gonna press Ctrl C. I'm gonna click here and press Ctrl C. And you can see close serial communication. Okay, so if you are running the script from the terminal, well, to kill the script, you just do Ctrl C. And if you are running it directly from Sony Python IDE, well, you need to click here and press Ctrl C. Okay, if you click on the stop button, it's not gonna do the same. So make sure that you click here and you press Ctrl C. Okay, close serial communication. As you can see, well, we receive the string every second, that's great, but we still have some new line and some characters that actually are not part of that string. So when you receive something with read line, you may often have some new line characters that are added or some carriage written. And in that case, what you can do is after decode, you can do dot strip. So this function is going to remove any new line character or any carriage written that you have on a string. So you just have the hello from Arduino and nothing else. Okay, let's run that again. Serial OK. You can see hello from Arduino every second without any other character. I click here, I press Ctrl C, close serial communication. And one thing I want to show you is if you look at the, so I'm gonna run the script. If you look at the Arduino board, you will see the TX LED is gonna blink every 1 second at the same time that you send the string. All right, you can see here. And now I'm gonna do Ctrl C. Okay, and it stops blinking, and now, well, it's just powered on. And so basically you have this TX LED that's gonna help you also see when you are sending data from Arduino to Raspberry Pi. So T means transmission. And so it's yet another tool to help you see what's going on in your application. And one last thing I want to show you is that actually, let's say you use a different baud rate here. So let's say I use 9600. I still use this one on the Arduino, but I use that one on the Raspberry Pi. So let's run the program. And let's see what happens. Serial OK. So the communication can be started. Great. But then, well, it seems that we don't receive anything. Okay, the communication is not working. So you can see that if you don't have the same baud rate, you're going to have weird behavior because the communication is going to be opened, but then anything else here is not going to work. Okay, I press Ctrl C, close serial communication, but we haven't received anything. Okay, I go back to this one. Let's run the script and serial OK, hello from Arduino, etc. I press Ctrl C and it's working correctly. So baud rate, super important. Okay, you can send some data from your Arduino to your Raspberry Pi, and let's start again to see how to send data from the Raspberry Pi to the Arduino. And so we are not going to start from scratch, okay? I'm just going to remove that code here and that code here. So we keep the same structure. On the Arduino, we're gonna initialize serial and make sure it's up. And on the Raspberry Pi, well, the same thing. We open the serial, we wait a bit, reset input buffer, and then we have this infinite while loop, which is basically the same as void loop, with the except keyboard interrupt to close the serial communication when we kill the program. Okay, and here we're gonna do our stuff here. So, as always, let's start with Arduino. Here, what we want to do is we don't want to send data, we want to receive data. And to receive data, well, we're going to do basically the same as what we did previously with the Raspberry Pi, which is to first check if we have received some data, and if yes, read the next line. Okay, so what we can do is if serial dot. So we have a function which is serial dot available. Okay, you can see it should turn orange. So parentheses. If this is strictly greater than 0, then we have received some data. So this function is going to return the number of bytes that the Arduino has received in the buffer, which is the same thing as the serial in waiting attribute we had in the Raspberry Pi, okay? That's the same thing. So this is the number of bytes. We don't really care about the number of bytes. We just care that the number of bytes is greater than 0, which means we have received something. If this is the case, well, I'm gonna just put string, let's say message, is equal to, we can do serial.read string. This is going to read the next string, so it's gonna also decode it and put that inside a string message. So very simple. Now, if you do that, and that's where I'm going to talk about the timeout. So basically there is a reading timeout of 1 second by default. So when you use this, the program is gonna be stuck for at least 1 second. Okay, so basically, as long as you receive some strings, it's gonna wait 1 second to be sure that it hasn't received more than what you've already received. And so if we just run like this, and then we send data from the Raspberry Pi to the Arduino, well, we're gonna see some delay in the processing on the Arduino. So what we can do, there are two options. The first option is to do serial.set timeout with, so the default is 1000 milliseconds. What we can do is maybe put 10 milliseconds. So that's gonna be much faster, but still it's gonna be stuck for at least 10 milliseconds. And the lower you go, actually, the higher the risk of missing some data or of just reading so fast that you don't receive everything and you receive an incomplete message. So 10 milliseconds should work, but I'm not going to spend too much time on this because we are not going to use set timeout. Instead, I'm going to use another function which is read string until, and I'm going to put the \n character with, and this is important, single quotes and not double quotes. Okay, single quotes, again, this is super important. So this function is gonna read the string until it gets to this character, and this function is gonna return as soon as it detects this character. So the timeout still applies, so we still have a timeout of 1 second that's gonna block this 1 second, but if you receive that character, the timeout doesn't apply anymore and you just get the string. So basically, if we send here from the Raspberry Pi a string with a \n character at the end, so a new line, then we're gonna be able to read it immediately with this function. And so this is basically the function I'm gonna use for all the course, read string until, which is quite powerful, quite efficient, and it's gonna give us directly a string that we can process afterwards. Okay, and then once we have received this message, well, we can process it and do whatever we want in the Arduino, all right? Now I'm gonna go back to the Python code on the Raspberry Pi. So first I'm gonna upload that actually to the Arduino. So now it's running and it's waiting for data. On Python, if you want to send something on the serial, what you can do is do ser, so you use a object we have here, okay, from serial dot write, and then you're gonna put what you want to write. Let's say hello from Raspberry Pi, and we are going to add a \n character at the end. So that's very important, okay, because if you don't send that, this is gonna wait 1 second. So it's still gonna receive hello from Raspberry Pi, but after 1 second. If you add the \n, as soon as this function detects the \n, it's gonna return with this exact string and nothing is gonna be stuck. And then, well, coming back here, as you have seen previously, when we read data from serial, we need to decode it. Well, here, when we write data, we need to encode it. So you're gonna do dot encode with UTF-8. So the same UTF-8 as before. And it's very important here that the dot encode is directly on the string, okay? You don't do this, okay? You don't do ser.write and then dot encode, no. You do ser.write with the string dot encode and then you end the parentheses here. Okay, so make sure you have the correct order for the parentheses. That's super important here. All right, so this is gonna send hello from Raspberry Pi to the Arduino. Maybe we can change the time slip here. Let's put 1 second, so we send this every second. Now the code is running on the Arduino. I'm gonna run the code also on the Raspberry Pi. Let's see what we get. Okay, serial, okay, so it's running. Actually, let's do Control C and let's add a print here. Print. Send message to Arduino. All right, so we can have a better idea of what's going on. Serial, okay, send message to Arduino, etc. Now, well, what we did before when we actually sent some data from Arduino to Raspberry Pi is that we could directly print the data we got on the terminal here, or on the shell. But now we send data from Raspberry Pi to Arduino, and how can we actually check and print and debug this data we've received? We could do serial.println with the message, okay? But the thing is that here on the Arduino, we are using println to send message to the Raspberry Pi and also to debug. Okay, so you can't just use this to print the message, for example, on the serial monitor, because you're already using the serial communication with the Raspberry Pi. So that's one thing that is very important, is that on the Arduino side, well, when you receive something from serial, don't just print it, or you can just print it like this if you want to test just with the Arduino and the serial monitor. But then when you communicate with the Raspberry Pi, don't just print some logs or some debugs. For example, here, if you print serial communication ready, here if you print received some string, well, everything that you print actually is gonna be sent back to the Raspberry Pi. Okay, and that's something you don't want if it's just for debugging. So, well, we are left with this. And, well, how to debug that? That's actually a good question, and there are different ways to do this. So first, of course, as I told you, you could just print what you received, run with the serial monitor, check if everything good, you just remove the print. Another option would be to use an external component. For example, an LCD screen that you plug to your Arduino, and that's actually what we are going to do in the following of this course. So you could receive some stuff from serial and print that on the LCD screen. And what you can also see as a confirmation that things are working, I mean, at least that you receive data here, is, so let's run the script again, and let's look at the Arduino board. And you can see the RX is blinking every 1 second, and now I'm gonna kill this, okay, and the RX is not blinking anymore. So RX is for reception. So as you can see, if the RX LED is on, it means you are receiving data on the Arduino. All right, and now that we have seen how to send data only from one side to the other, let's check how to do a bidirectional communication. Let's now see how to combine together the two sides of serial communication. And we're going to start from the previous program where we send something from the Raspberry Pi to the Arduino. What we are going to do is we are going to send back the message to the Raspberry Pi with something that we add here, okay? So this program is already working. If you don't have this, please go back to the previous video. So what I'm going to do is I'm going to add something to the message here. For example, a counter that we're gonna increase every time, okay? So we can see a progression on the messages. So I'm going to create here a global variable int counter is equal to 0. Let's initialize it to 0. And so once we receive the message, what we are going to do is to do message is equal to, so message plus, let's add a space, plus let's add the counter. The counter is an integer, so we're gonna need to convert it to a string, so we use string with counter. So if we receive hello from Raspberry Pi, we're gonna now transform it to hello from Raspberry Pi 0, and then 1, 2, 3, 4, etc. So of course, if we want to increase the counter, we do counter plus plus after we have used it. And then, well, here we receive some data, we transform the data, and we can do serial.println. Let's do serial.println another time with message. All right, and let's run that on the Arduino. Let's upload this. Done uploading, and actually before we write anything on the Raspberry Pi side, we can already debug this program, because here we will be able to see the message with println, which means that we can do with the serial monitor. Okay, so I open a serial monitor and I'm gonna send the string, let's say ABC, and you can see I have ABC 0. Okay, I send another string, a random string, I have 1. Okay, hello, hello 2, hello 3. So we know that the Arduino program is correctly working. So we send a string, we also have, so that's very important, we have new line. So with new line, that's gonna add a \n at the end, okay, a new line character. If you want to add nothing, you go with no line ending, but I'm gonna keep new line, okay? So you send a string and you receive the string with a space and with a counter that increases every time, all right? So now that we know it's working on the Arduino side, let's go to the Raspberry Pi side. And here, well, we're going to send a message to the Arduino. So let's keep hello from Raspberry Pi, great. And then we're gonna receive this message. So as you can see here, we directly read the string, we modify it, and we send it back. So it should be almost immediate, okay? So I'm gonna stay just after the write and then read the string. But before that, as let's say a way to be sure we have received the data, I'm gonna do while ser.in waiting is lower or equal than 0, which means that here we check if we have received some byte. If this is equal to 0, well, I'm gonna do time.sleep 0.01. Okay, so we're gonna wait 0.01 second in an infinite loop as long as we haven't received any data. Once we have received data, what I'm gonna do is I'm gonna do ser, so basically the while loop is gonna exit. I'm gonna do ser.readline dot decode with utf8 dot rstrip, and I'm gonna put that inside a variable named, let's say, response is equal to that, and then let's print response. Okay, so every 1 second we send a message to the Arduino, we wait until we receive something, we read that thing, we print it, we go back to the beginning. What you can see on the Raspberry Pi, and I'm coming to that now, is we also have a timeout is equal to 1 here when we open the serial communication. So basically we set a 1 second timeout, the same that we have on the Arduino, but on the Arduino we don't need to write it to have 1 second. If you don't put this, it means you have infinite timeout. And the timeout is actually not a timeout for everything, it's a timeout for when you read with serial. So when you use this read line, basically it's gonna do the same thing as here. It's gonna read the next line, okay, until basically this \n character. So if you receive something that ends with a \n character, it's gonna return immediately. If not, it's gonna wait at least 1 second. So normally, if you correctly put \n with println here, you should not have any timeout problem. But I have still included it here, okay, just in case, so we don't have an infinite timeout that's gonna completely block our code if we have one error coming from the Arduino. Okay, the Arduino is correctly running the code. Let's run the code on the Raspberry Pi. Serial OK, send message to Arduino, you can see, and hello from Raspberry Pi 1, 2, 3, 4, etc. etc. I press Ctrl C. And you can see it is correctly working, so now you have a bidirectional communication. Alright, and that's the end of this YouTube tutorial. I hope you could learn a lot from it. Now, if you want to go further and continue to learn with me, then I have a complete course for you on Raspberry Pi and Arduino, which contains 9 hours of video content and many projects to practice more. So in this course, I will also give you more details about when to use a Raspberry Pi, when to use Arduino, and when to use both at the same time in a project. Okay, then a few installation steps, and then the first part of the course is actually basically what we did here in this YouTube crash course, but I also include more debugging explanations here. And then we have a complete section on practicing. So you will practice with 3 different activities on serial communication. After that, we are going to go to the Arduino side. Okay, and on the Arduino side, as you can see here, well, we are going to create some circuit with many different components. So LED, push button, buzzer, LCD screen, servo motor. And after we have built this circuit, we are going to also practice more and practice with the Arduino functionalities that we also control from the Raspberry Pi side using the serial communication. So that's the Arduino side, and then we are going to go to the Raspberry Pi functionalities. So here we will focus on the camera, so how to get photos with Python on the camera, and also we are going to create a Telegram bot. So the Telegram app here, you can see it, and we are going to create a bot so that we can actually control the Raspberry Pi from the Telegram bot. And then, well, we have more practice with everything combined. So in those practice activities, we are going to actually control the Arduino from the Telegram bot, for example. And that's not all, because at the end we have a complete intercom system. Okay, so if you can see here, okay, for example, I will press on the button to call, and then you can see we receive a message on Telegram with a photo that's taken by the Raspberry Pi, and we can send a command to accept, for example, and then the LED will turn green, the servo motor will open the door, and then after a few seconds, the door will be closed. And so you can see here we have a complete Arduino circuit with a Raspberry Pi connected to the Arduino, the camera, the Telegram bot. Well, everything will be combined in this final project with many different steps. So at the end of this course, you will be a pro on how to use Arduino and a Raspberry Pi in the same project and how to take the best of each board to create amazing projects. Alright, thank you for watching and see you in the course or in the next tutorial.